Hello, this is Jim, W9JUG, with part 2 of the circuit analysis of this circuit right here. In part 1, we determined that the current through the 12 ohm resistor was 5 amps. Knowing this now, we can solve the circuit using Kirchhoff's laws and Kirchhoff's current law. If we look at this very closely, we have 60 volts plus 84 volts is 24 volts. If I look at the voltage from A with respect to B, which we call voltage AB, it's plus 24 volts. Okay? Now, that means that the voltage then from here to here is the same as here to here, so the voltage across the 6 ohm resistor is 24 volts. Ohm's law says we have a current of 4 amps going through the resistor. So, alright, the 5 amps comes down here to this point, okay, and branches off. 4 amps goes this way. And that develops a voltage of 24 volts. Notice the voltage from here to here is the same as here to here. See? Now, to further correct the circuit here, we see that the current going in here is 5 amps. Now, Kirchhoff's current law says the current entering a junction must be equal to the current leaving that junction. Well, we leave it in 2 ways. One, we got the 4 amps through the 6 ohm resistor, and we're left with 1 amp through this part of the circuit. Through the 3 ohm resistor, the 1 amp comes up to this point, where it joins with the 4 amps to produce the 5 amps. So essentially, this circuit is solved. The original current direction for this loop was incorrect. It's not a mistake, it's just we assumed that the current through this 6 ohm resistor was I1 plus I2. Okay? But because of the dominance of this voltage source, 84 volts, better than 3 times this one is predominant. But this one also enters into the circuit, and that's why we needed to use some advanced circuit analysis to solve this particular problem. So the whole thing is now solved. We know that the voltage from here to here is 23 volts. We had a positive 3 and a positive 21. That's positive 24. That's the same voltage that's over here. And the key for the circuit was finding this voltage right here. Once we have found the voltage across the 12 ohm, we can simply add those voltages, okay, and then solve the circuit completely. This is not the only way for the solution of the circuit. There are other network theorems, like Norton's theorem and Thevenin's theorem, that will be discussed in future parts of this presentation. Using this circuit as a standard, and we can show that those parameters using the Thevenin's or Norton's will come out the same as it has in this one. Thank you for watching. This is Jim, W9JUG, and by the way, if you have any questions, my email address is w9jug@outlook.com. I have a written narrative on this circuit also, which I can supply you. Thanks for watching. Have a good day.